Now, your flow rate calculations in the IV run or the batch, generally calculated on a 24-hour supply. Things we might need to determine include how long the bag's going to last, what time we need the next bag, how many bags we need for 24 hours. So we can use different ways to calculate those need-based calculations. So 3 methods for solving IV flow rate questions are best used in sterile compounding scenarios. The infusion rate in milliliters per hour is given on the CSP label. The total volume provided on the medication order or the CSP label, and the current time. So those are the items that we would need to find out how long will this bag last, or what time do we need the next bag. So to answer the 3 questions, when calculating IV flow rates, you have to know the total volume, the infusion rate, and the information can be found on the label. Drop factor relies on specific drop factor of the tubing. So how many drops per milliliter? Each of the different types of tubing will give a different drop factor. Macro tubing could be 10 drops per milliliter, 20 drops per milliliter, 15 drops per milliliter. Now a micro tubing, there's only one size, and that's 60 drops per milliliter. So that's an important one to remember, because that only comes one size. And then we use those drop factors to create the IV drip calculation. So, for example, this is what it would look like. The total volume in milliliters with the time in minutes, and then our drop factor in our milliliters. So if we're doing an IV that's a piggyback, generally it'll be infused over 15, 20, 35, 45, or 60 minutes. That one would give it as in minutes. If you're infusing a large volume parenteral, you may have to do an extra step in here to convert your milliliters per hour into minutes. The pharmacy also may use alligation calculations if we're mixing 2 different strengths of the same ingredient, or if we're doing a dilution. I know that you learn dilutions as a separate calculation, but dilutions can also be solved using an alligation, where your bottom concentration is 0 because you're using water or some other base that doesn't have any active ingredient in it. So you can review the alligation, and we'll go over this when the appropriate time comes. But this is just the process of alligation. The book does discuss it. You also did it in math, and I believe in pharmacy practice. So calculating skills, it's really important to have accurate calculation and measurement of the components that we're doing. We don't have a way to correct once a fluid solution has been administered to a patient. So if it's made improperly, it actually could cause a patient their life. So we really need to make sure that we're doing all our calculations properly. All right. So which one of these is the basic formula? All right, D over H is equal to X. Remember, that only works if your original concentration of the drug from stock is over 1 milliliter. An equation using drop factor is sometimes called what? If it's got drop factors, it's a drip rate. All right, very good. Some questions for you.